Hello, my name is Jordan Bush. I am a master's student from the University of Kentucky. My poster is titled Application of Remote Sensing to Quantify Warm Season Grass Encroachment in Pastures. Anecdotal evidence from farmers in our region suggests that larger quantities of warm season grasses are being seen in perennial pastures in recent years. Traditionally, hand sampling methods would be used to quantify the warm and cool season grasses present in a pasture. However, sampling by hand is labor-intensive and time-consuming. Remote sensing has been used in other crops to monitor different agronomic attributes, so it may also be a rapid and effective way to detect and monitor these long-term shifts in the percentages of cool and warm season grasses in pastures. The objective of the study was to determine the accuracy of digital photography and drone imagery to estimate the percentages of cool and warm season grasses in perennial pastures. This study was conducted at the UK Research and Education Center near Princeton, Kentucky, which is in western Kentucky. It was set up in a randomized complete block design with 3 replications per treatment. Each paddock was approximately 0.8 hectares or approximately 2 acres. Wheat was planted into the paddocks in fall of 2019, and in the following spring, strips were sprayed out of each paddock using a non-selective herbicide to create strips of brown and green. The treatments included 25, 50, and 75% green canopy cover left over. 30 images were captured in each paddock using a Nikon D750 digital camera attached to an extending pole so that the lens was pointing straight down to the ground, approximately 3 meters high. Camera images were collected on 2 different dates and then analyzed using the Canopio program to obtain green canopy cover percentage for each photo, and then the green canopy cover percentages were averaged to provide an overall estimate for the paddock. The Canopio output was then compared to the known values for each paddock. Figures 1 and 2 show the input and output photos from Canopio. So the green pixels are converted to white and the non-green or brown pixels to black. And the program then provides a percentage of green for each image. For example, this image in figure 1 is just over 38% green canopy cover. Table 1 shows the green canopy cover averages for each treatment between the 2 dates, and then figure 3 displays the same data as the table and includes R-squared values. So in summary, there's a strong relationship between digital imagery and the direct measurement of the strips for both dates. The digital imagery did, however, underpredict the green canopy cover for both sample dates. This underprediction may have been due to the large presence of seed heads and flowers of weeds in the pasture that were white and yellow, which did not register as green canopy cover. The higher prediction values for the second date may be attributed to the rainfall that occurred between the 2 dates, which resulted in weeds sprouting in the areas that had been sprayed. Drone imagery was collected for this study and is in the process of being analyzed. Red, blue, green, NDVI, and NDRE data were collected with the drone. This study will be repeated in the spring of 2021 as well. So thank you for listening to my presentation. I look forward to hearing feedback, and I am happy to answer any questions.